Welcome back, everyone. In this lecture, we're going to discuss a little bit about the theory and ideas behind exponentially weighted moving average models, otherwise known as EWMA models. Now, previously, we've seen how calculating a simple moving average can allow us to create a simple model that describes some trend level behavior of a time series. So for example, we have this thousands of passengers data set, and depending on what window size we choose for our simple moving average, we can begin to describe the generalized behavior. And if we use a longer window size, such as a 12-month window size, we grab the general trend, and if we choose a shorter window size, we can then grab the kind of more detailed behavior of that time series. So we can grab a little bit of that seasonality, such as the orange line for a 6-month simple moving average. Now, we could theoretically attempt to use these simple moving averages to build a generalized model for the real-world time series we're analyzing. However, later on, we're going to discover much more sophisticated models for this, so don't think of this section quite yet as a forecasting method. Just think of it as trying to create a generalized model to describe the general behavior of your time series. So what we're going to do is we can expand off the idea of a simple moving average by utilizing what's known as an exponentially weighted moving average, or EWMA. So an issue with SMA is that the entire model will be constrained to the same window size. So for example, previously we chose a 6-month window size or a 12-month window size. We have to use that window for the entire data set, even if it's much longer than just 12 months or 6 months. So we can have a data set of 100 years or 10 years. We still have to choose a single window size for all that data. So what would be nice is if we could have more recent data be weighted as more important than older data, because if it's more recent, then it's probably more reflective of upcoming future results. So we can do this by implementing an EWMA instead of an SMA. So an EWMA is an exponentially weighted moving average, and what it does is it attempts to overcome some weaknesses from basic SMA, simple moving averages. So some of those weaknesses are that in basic SMA, smaller windows will lead to more noise rather than signal. So it's hard to balance the window size because as you go smaller, you are being more accurate as far as what you're able to model from that generalized time series, but you start picking up more and more noise. And unfortunately, with SMA, you're always going to lag by the size of the window. And what's going to happen is you never end up reaching to a full peak or valley of the data due to that averaging. So if you look back at that chart we just showed, you'll notice that it's really hard to actually get a window size that is going to fill up those peaks and valleys for seasonal data, even if you choose very small windows. And the other issue of SMA is, in reality, it doesn't really inform you about possible future behavior. All it really does is describe general trends in your current data. And extreme historical values can skew your SMA significantly. So if you're trying to model economic data and there was a recession, then that dip is actually going to be reflected for the entirety that the window passes over that recession, which may or may not be accurate. So to help fix some of these issues, we can use an EWMA, that's the exponentially weighted moving average. So EWMA will allow us to reduce the lag effect from SMA and will put more weight on values that occurred more recently by applying more weight to the more recent values, and thus that's where the name comes from. It's exponentially weighted. So the amount of weight applied to the most recent values will depend on the actual parameters used in the EWMA, and we'll talk about those parameters, and we have a further explanation in the notebook that goes along with EWMA. And it's also dependent on the number of periods given a window size. So what we're going to do is in the very next lecture, we'll code out an example of using pandas to create EWMA, and that's coming up right after this. We'll see you there.